Hello and welcome back to PA Academy. So we are still looking at Supermesh and this is example 3. Now in this example 3 we have this circuit and we are asked to look for I1, I2 and I3. So if you have been following this video under Supermesh, you see that this example is similar to, it looks similar to the one we looked at in example 2. But there's a little tweak here. So I want you to pause this video and attempt it and let me know. And once you are finish attempting it, just keep your answer and then let us do it together and let me know if we arrive at the same answer. So I want you to pause this video and try to attempt it based on the knowledge you have so far on the previous examples that we've looked at. Alright, so without wasting time, but let me start with my own solution. I hope you've also completed yours and you've already gotten your answer for your I1, I2 and I3. So just do that just to test your knowledge on what we've looked at so far. So now to start with, like I said, we are going to write out the equation of our current source. So since we are dealing with Supermesh, so equation of current source. I hope you can see that. Okay, so equation of current source, in drawing that, you can see that unlike in the other examples, it's looking like this, horizontal. So, but now we're having it to be vertical. So let me just draw that. So we're having something like this now. And we are giving it to be 5 amperes. All right, so there are two current in that direction. We have like this, that is I1, and then we also have in opposite direction, that is I3. And don't forget, I said when you are to write the equation of the current source, you look at the one that is in the same direction with the given current source, so which is I1. So that means you're going to be having I1 minus I3 equals to 5 amperes, and this is our equation 1. So this is always very easy to deduce. You can just get it very easily. So now having done that, now let's go ahead and draw the Supermesh circuit. All right, so this is where there's a little difference compared to the other example that we looked at earlier. So in drawing that, we are going to be having something like this. Okay, so don't forget, we are going to be joining the mesh that is sharing this current, that have this this current in between them. So we are going to be having something like this. Okay, and don't forget that like I said in the other example, if you have other elements in that branch where we are having the current that is being shared between two meshes, you are going to omit everything together. So we are not going to be adding this 2 ohm resistor in this Supermesh circuit. So this is how it's going to look like. So let's go ahead and add the values. So here is this resistor is 3 ohms. This is 1 ohm, and then this is also 1 ohm. And then we have a voltage source of 10 volts. I think those are the 3 elements we are having there. So let's go ahead and add the polarities based on. Okay, so there's one thing we didn't do here. I didn't have the polarities here, so let me just go ahead and add it. So for the voltage source, this is plus, this is minus. So based on the direction of the current for I1, this is going to be plus, minus. I want to believe this should be very simple by now. You should have gotten how to do this. So if you have watched the video on that mesh and now Supermesh, so this is going to be plus and minus. So for I3, this will be plus, minus. So this will be plus, minus. So just in the direction that you have chosen, this will be plus, minus. This will be plus, minus, plus, minus. And then due to I3 in this 3 ohm resistor, this is plus and minus. So they are going to be having the same polarities here. So let's start from this 1 ohm resistor. So this is going to be plus and minus, and the current that is flowing through it is I3, like we are having here. So in this 3 ohm resistor, we have 2 current flowing through, which is I2 and I3. So this is going to be plus and minus, and the current in that direction is I3. Why this will be plus and minus, and the current in this direction is I2. Why for this? In this downward direction, we have the current here to be I1. So that's plus, minus. Why on this side is plus, minus, due to the current in upward direction which is I2. So I hope everything there is clear and is not too choked up or jam-packed. Alright, so let's continue. So having done that, let's apply KVL to what we're having here. So let's just take it from these points and then we go around and come back to this. So let's apply KVL. Apply KVL. So once we start from here, going upward, so this is plus and minus, the polarity of the voltage source. So from minus to plus, that's going to be 10. So the 10 will be there, so that will be 10. So the first element will come across is this 1 ohm resistor. So from plus to minus due to the 1 ohm resistor, so that's going to be minus 1 I1. Also we have from minus to plus, from negative to positive due to I2, so we are going to be having minus 1 I2. So we are done with the 1 ohm resistor, this 1 ohm resistor. So let's continue. We come here to the 3 ohm resistor. So we are having from positive to negative due to I3 on this 3 ohm resistor. So we are going to be having minus 3 I3. So from negative to positive due to the current I2. So we are going to be having plus 3 I2. That is done for here. And then once we get here from positive to negative, so that's going to be minus 1. And don't forget this is 1 ohm resistor. So that's minus 1 I3. So we have only one current flowing through it. So this is the only thing we are going to be having here. And equals to what? Equals to 0. So now let's simplify this. So I like to arrange them accordingly. So I1, we only have 1 I1, that is minus 1. Am I correct? Alright, so we have only one value for I1, so that's going to be minus 1 I1 is same as minus I1. And then for I2, let's see, we have minus 1 and then plus 3 for I2. Okay, so at this point here, this is supposed to be plus, so you have to be careful of this. This is plus. This is minus 1 I1 plus 1 I2. That's because of this 1 ohm resistor. This is from positive to negative. That's why we're having minus 1 I2. And you're also having from negative to positive due to I2. So this is supposed to be positive, not negative. So with that, our I2 is, we're having plus 1 I2 and then plus 3 I2. That will give us plus 4. Plus 4 I2. And then for the I3, we are having minus 3 I3 and minus 1 I3. That will give us minus 4 I3. Equals to, so we are having 10. If you bring 10 to the other side of the equals to sign, it becomes minus 10. And this is our equation 2. So now we've gotten our equation 1, we've gotten our equation 2. So let's go ahead and solve the third mesh. That is this. Let's call this mesh 2 because we're having current 2 there. So let's call this mesh 2. So let's go ahead and apply KVL also to mesh 2. Now we've been able to simplify the circuit that is the super mesh itself, where it is having a current source between two of them, between the two meshes. So now let's go ahead and do, so let me just draw a line here. Okay, the black markers are yet to come up. So let me just, so that you don't mix everything up. So let's use this space to apply KVL to this mesh 2. So we're going to be having apply KVL. That's Kirchhoff voltage law to mesh 2. So this is what we've taken to be mesh 2. So we are going to go around this particular mesh. So let's say from here, go around it in a clockwise manner. So that means here, and then we come back here. So from here, if you go here, the first element you are coming across is this 2 ohm resistor. So from positive to negative, so that's going to be minus 2. And then the current there is I2. So when we leave there, we come to the 3 ohm resistor. So from positive to negative, due to current I2, that's going to be minus 3 I2. While from negative to positive, due to current I3, so that's going to be plus 3 I3. Now let's come to the 1 ohm resistor. From positive to negative, so that's going to be minus 1 I2. The current at that point is I2. While from negative to positive, due to current I1, so that will be plus 1 I1 equals to 0. So let's rearrange and simplify this. So I1, so this is the only I1 we're having here, so that's 1 I1. So what about I2? So this is minus 2 I2 minus 3, that's minus 5, and that's minus 6. So that's minus 6 I2. Then for I3, we are having only just plus 3 I3 equals to 0. Alright, so that is it. This is our equation 3 and equation 3. So now we can go ahead and solve equation 1, 2, and 3 simultaneously, and that will give us our answer for the value of currents I1, I2, and I3. So let's do that. So let me just write out the equations. So for I1, this is going to be, you can write this as 1 I1. So we don't have I2 here, we can just give it either plus or minus 0 I2, because it will still be 0. Then minus 1 I3 equals to 5. Then from equation 2, we are having minus 1 I1. So minus I1 and minus 1 I1, we are still saying the same thing, plus 4 I2 minus 4 I3 equals to minus 10. For equation 3, we are having it to be 1 I1 minus 6 I2 plus 3 I3 equals to 0. So if you should solve these three equations simultaneously, you are going to get I1, I2, and I3. So if you should do that, whichever method you want to use, maybe like the calculator method I was using earlier, using your calculator, whichever one you want to do, you are going to get your I1 to be what? 8.571 ampere, 8.571 amperes, and then you are going to be getting your I2 to be 3.214 amperes, and then your I3 will be 3.571 amperes. So these are the value of I1, I2, and I3 as the current flowing in each of those meshes based on the direction we've chosen. And this is to say that since all the answers you are getting here are positive, let me see in the next examples we are going to be looking at. Alright, so this is to tell us that all the direction that we assumed for this particular circuit, all the clockwise direction, that means all the currents are flowing in that direction. So that's to tell us that the direction we picked is in line with the assumed direction is actually the real direction. That's why we are having the current to be positive. I want to believe you understand what I'm saying. If you've watched the video under mesh analysis, you get what I'm saying. Alright, so this is it for example 3, and in example 4 we are going to be looking at a circuit with four meshes. If you look at the previous examples we've been looking at, most of them are just 3 rather. So we are going to be looking at a circuit with 4. So if that interests you, make sure you don't mix example 4. So, and also if you solve this question before I actually started solving it, like maybe to test your knowledge, and you arrive at the same answer, do let me know in the comment section below. And if you got a different answer, so just go through it and let me know where you got the mistake, where you got it all wrong, and then let's talk on the comment in the comment section below. Alright, so thank you very much for watching. This is still PA Academy. If you find value, please give it a thumbs up. If you are here to subscribe, please subscribe to this channel. Also check out our website, paacademy.co. 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 Alright, so thank you very much, and I'll see you all in example 4.